Yes. This I'm looking. This is my expertise about the PID, PFD, and also process flow diagram. Okay. I really want to ask this question. Okay. Looking for the process, we have mixing and the dissolution process. Every time of the process we evolve must be have time. Alright. You not mention about the time, how many time the process you're all supposed to have all the time process here. Okay, let me ask one question. For the mixing and dissolution of the process, how many hours or how many time you take for the one batch 3000 kg? Can anybody answer that?
Thank you for the question. I would like to answer your question.
Yes.
Okay. So based on the calculation that we did, the time taking for mixing process of buffer solution with a mass flow rate 2,000 kg per batch with a whey permeate powder of mass flow rate 1,000 kg per batch to dissolve 3,000 kg per batch of diluted whey permeate is taking about 1 hour.
Alright, good. So that means your process from mixing to dissolution of the process, sodium phosphate powder and buffer solution sodium phosphate equivalent 3000 kg is about 1 hour, right? Okay, so next time you put the T1 1 hour, T2 2 hour. You understand what I mean? Okay, when you run the process in the line, we are looking for time. Time is money. Okay, I repeat, time is money. The longer you put down in the process, the waste time, the more energy you use, the more money will go out. Understood? Yeah. You are engineer. You have to know this. Okay. All right. Okay. I go to not by one. I go to specifically very important process. So such as in the process I saw is the main process is the reactor. Okay. Reactor process. Reactor is where the enzyme you have to control the pH, the pressure. So the enzyme is very important. It's the temperature and pressure to reaction. Okay. So can I know in the reactor how long the process in the reactor and what the reaction and enzyme involved in the reactor? Can you explain?
I will answer your question. Okay, so in the packed bag reactor, the operating time taken for the fermentation is 4 hours, and based on our finding, the best enzyme that we choose to produce gauze powder is beta-galactosidase from Galactis, and the optimum temperature for the enzymatic reaction is 40 degrees with pH 7.
Alright, good. So you have to remember, enzyme, the most important, every enzyme in the world, you name it amylase or whatever it is, the most important thing is the temperature. Remember? So when we're talking about temperature, you must be optimum temperature. The optimum temperature is where the process reaction enzyme is started in very good condition. You have to have a good pressure, good pH, good temperature. Okay, this thing you have to control inside the reactor. Okay, so I just want to add a little bit about reaction inside there. So in the design, you have to control the temperature and pressure inside the temperature. So because when the temperature is going up too high, mean more than 40 degree, let's say 45 or 50 degree, your enzyme is too active. Understood? When the time the enzyme is too active, the reaction during the changing the lactose will become inefficiently. Yeah, understand? And also the pressure. So the best way you have to control the reactor. Usually they have a jacketed. Okay, so you use jacketed or insulated reactor?
Insulated.
Okay, so insulated normally in a reaction it will be generate heat. Okay. Okay, so the best is enzyme to put good reaction is you have to put jacketed. Okay, jacketed, you can control either you increase the heat temperature inside the reactor or you can reduce. So because we have to maintain the optimum temperature 40 degree and also the pH and also the pressure. All right. Okay. I have a lot of questions, but I pick very important instrument lah. Alright, let's go to the cooling. Before go to the enzyme cooling. What type of heat exchanger you are using? You are using tubular heat exchanger or plate exchanger?
Based on the that we did, plate heat exchanger is selected for our cooling process.
Alright. Why you use plate exchanger instead of tubular exchanger? Is it tubular exchanger is very good flow rate? Why?
Because a plate heat exchanger has greater heat transfer area, so a bigger flow rate can be used to cool down the waste solution from 85 degrees Celsius to 40 degrees Celsius with duration 1 hour.
Alright, so this is stated. So you justified. You as a process engineer, you have to justify every time instrument that you use. Understood? So, let's example, we have a lot of the heat exchanger in the market. We have tubular heat exchanger, we have set surface exchanger, we have plate exchanger. So, why we use plate exchanger? Because a good energy transfer, because there is a big surface area. But you have to remember when you use the plate exchanger, the flow rate will be lower than tubular heat exchanger, right? Yeah, you have to understand. Okay, I go to the last one. I think for this process is the spray drying. Okay, spray drying is the process where you remove the moisture content inside the liquid to become the powder, right? Isn't it? Yes, isn't it? Alright, the most important thing in the spray drying is the moisture content. Can you explain me how many percent you remove the moisture content inside the spray drying? Good.
Okay, based on my finding and calculation, the moisture percentage removed during the spray dry is around 98%. So that can produce about 338 kilograms of gauze powder per batch.
Repeat again. How many moisture content percentage you remove?
Moisture content removed is 98%.
98%. So that's mean 2% still retained inside the powder, right?
Yes.
Alright, good. So based on the calculation, mean 2% of moisture content is inside the powder is good enough. If too dry, we have problem of the flowing inside the pipe. Okay, because we have occurred we call it lumpy issue. Why we have a lumpy issue? Because the fat inside the spray in the powder is more than they have no moisture inside the powder. We call it lumpy issue. Dia akan sangkut dekat pipe. Okay, very good. Next slide please. Dr. Nadia, dah tanya apa Dr. Nadia? Tak dengar Dr. Nadia.
I don't have any questions. The ball is on you.
Alright, good. Okay, this is what is this? PFD? PID?
This is PFD.
PFD.
Yeah.
Okay. PFD is the process flow diagram. Okay, process flow diagram, you have to show the flow of the piping or the product. Understood? Different with the PID. PID, we show all the sensor and all the transmission, everything. Okay, so far very straightforward process lah, I see. Okay, so we can see here. I just want to see, this is where is the last before go to packaging? Where is the last part? Can anyone explain? Before go to the packaging.
Before packaging, there are 2 parts for our main product, gauze powder. It is spray drying, and for the glucose syrup, it is the holding tank.
Alright, so you have 2 product run in the plant, right? Another one is a powder, and another one is a glucose syrup. Glucose syrup is the byproduct from in the process, right? You remove during the evaporation, right? Isn't it?
Yes.
Okay, based on your PFD, you don't have, like we call it, Hooper lot cell. Alright, there is a lot cell where we measure the powder when you go inside before go to 10 kg. How you measure 10 kg inside the powder? Every bag, how you measure? You cannot measure, you don't mention here. So I explain the process here. When the last process go to before going to the bag or pouch, there has, we call it log cell to record the weight. Okay, they log like this. Let's say you're filling the powder until get this log cell. They have a sensor go to the PLC. So let's say you set the set point 10 kg, right? So they enough than 10 kg, they open the valve, they go inside they dump inside the bag or pouch, alright? So based on the drawing I saw, so make sure next time you have to put the instrument. This is more important thing where you can control the weight of the product. Okay, so the rest so far I see everything you have, right? Okay, next please.